In the world of high-precision manufacturing, the chase for perfection is just relentless. For decades, these tiny, almost invisible errors have piled up into massive problems, costing billions and really stifling innovation. But what if we could finally reach the end of error? Well, a revolution is happening on the factory floor, and it's powered by data, AI, and a completely new way of thinking. Let's explore how we're building a world with zero defects.
Take a good look at this number. Up to 30%. That's how much of a company's total production costs can just vanish due to scrap metal and having to rework faulty parts. It's a colossal hidden tax on the entire manufacturing industry.
I mean, when you're machining parts for aerospace or medical implants or high-performance engines, the tolerances are thinner than a human hair. We are talking microns. There is absolutely no room for mistakes. The stakes are just incredibly high. So the billion-dollar question is, why do these mistakes still happen? To really get where we're going, we first have to understand where we've been. See, this isn't about just a few bad parts here and there. It's about a fundamental inefficiency that has been a silent tax on manufacturing for over a century.
And it's not just us saying it. As Frigate Manufacturing confirms, this is a direct hit to the bottom line. Seriously, imagine taking nearly a third of your project budget and just setting it on fire. That's pretty much what happens every time a part gets tossed into the scrap bin. So, okay, if the costs are so astronomical, what's causing all these expensive failures? Well, it turns out it's not just one thing. It's a whole series of hidden culprits lurking deep inside the traditional manufacturing process. Let's break down the 4 main offenders, shall we? First up, you've got flawed toolpaths. These are the basic instructions telling the machine what to do. Then you get unexpected issues with the raw materials themselves. After that, tiny unseen vibrations in the workpiece that can throw a perfect cut completely off. And finally, a painfully slow manual inspection process that often catches these fatal flaws way too late. So let's start with the instructions, the toolpaths. Traditional toolpaths are, well, they're kind of dumb. They tell the machine to move at a fixed speed, which often overloads the tool, creating insane amounts of heat and wear. They even waste precious time just cutting fresh air between passes. Optimized toolpaths, on the other hand, are intelligent. They adapt on the fly, maintaining a perfect constant load on the tool, which extends its life like you wouldn't believe.
And this is where the new approach really shines. Just look at this modern waveform toolpath. Instead of these harsh, straight lines and abrupt corners, it flows like water. It's designed to work with the physics of the material, not fight against it. And the result? A faster, cleaner, and way more efficient cut. But here's the thing. Even if you manage a perfect cut, you run straight into the final roadblock, inspection. Traditionally, this is done after an entire batch of parts is finished. A person with a set of calipers checks a few samples. If they find a mistake, the whole batch, we're talking hundreds, maybe thousands of parts, could be completely worthless. It's a bottleneck that's slow, inefficient, and just riddled with potential for human error.
So, how do we solve all these problems at once? Well, the answer starts not on the factory floor, but in the digital world. Before a single piece of metal is ever cut, we run a perfect rehearsal. Welcome to the era of the digital twin.
A digital twin is exactly what it sounds like. A perfect, physics-based simulation of your entire manufacturing setup. Think of it as a digital proving ground where you can run the whole process virtually. You can spot collisions, you can fix errors, and you can optimize every single movement, all with zero risk and zero waste.
And just look at the level of detail we're talking about here. This isn't some simple animation. This software is simulating the actual physics of the operation. It's predicting the forces, the heat, and the stress on both the tool and the part for every single microsecond of the cut. It's the ultimate digital dress rehearsal.
And of course, the bigger and more expensive the part, the more critical this becomes. I mean, when you're machining a massive, single-piece aerospace component that's worth millions of dollars, you just can't afford a do-over. Virtual simulation goes from being a helpful tool to being an absolute necessity.
Okay, so we've tested everything in the virtual world and it's looking flawless. Now we need to generate the actual instructions for the machine, what's known as G-code. This is the precise language the machine understands, and this is where artificial intelligence steps in to write the perfect script.
So, AI-enhanced computer-aided manufacturing, or CAM, doesn't just create a toolpath.
It creates the optimal toolpath. It analyzes all the data from that digital twin and dynamically adjusts every movement to maximize efficiency and minimize wear. It's all about generating smarter code for much, much smarter cuts.
And the results? They're staggering. These aren't just small tweaks, these are massive leaps. We're talking a 15% jump in efficiency, 20% less material wasted, and a 30% increase in the life of the cutting tools. In an industry of razor-thin margins, these are truly game-changing numbers.
So, we've simulated it. We've written the perfect AI-driven code. But now we get to the final, and honestly the most exciting piece of this entire revolution. Machines that don't just blindly follow instructions, but can actually think, sense, and adapt in real time.
This right here is the holy grail, Zero Defect Manufacturing, or ZDM. The philosophy behind it is simple but so profound. Doing things right the first time, every time. It's a fundamental shift from catching defects after the fact to preventing them from ever happening in the first place. So how does it actually work? Well, it's a constant, intelligent feedback loop. The machine uses sensors to sense what's happening in real time, and AI analyzes that data to predict a potential error. Then, the machine instantly corrects its own path before the mistake can even happen. It's a self-correcting system. It's incredible.
And here's what that looks like in the real world. The machine scans the actual part it's working on, creating a live 3D model of it. And AI then compares that real-world scan to the perfect digital blueprint. If it sees any tiny deviation, any potential error, it adjusts the very next cut on the fly to correct for it. It's not just following a script anymore. It's predicting and preventing errors as they happen.
So when you bring all of this together, the perfect digital rehearsal of the digital twin, the AI-written script from Enhanced Cam, and the smart, self-correcting machine, you get the factory of the future. And it's not science fiction. It's happening right now. The impact is just enormous. We are entering a brand new era with drastically less waste, lower costs, and consistently higher quality. And that frees up resources and empowers companies to innovate faster, pushing the boundaries of what is physically possible to create. So what all of this really means is that we are at the beginning of the end of error. This technology isn't just about making the same things a little bit better, it's about enabling us to build entirely new things we couldn't even dream of before. Which leaves us with one final, very exciting question to think about.